Hello and welcome to another LeetCode video. Today we're going to be working on minimize the maximum difference of pairs. So in this problem, you're given a zero-index array nums and an integer p, and you want to find p pairs of indices of nums such that the maximum difference amongst all the pairs is minimized. So this is a little bit weird, so let's just kind of go through this example and show what they mean. So essentially we have an array, and we need to find, in this example, we need to find two pairs such that the maximum difference is minimized. So we want pairs as close to each other as possible. So the two pairs we're going to want, if we only want two, we're going to want 1, 1 and 2, 3, and therefore the maximum difference will be 1, right? This is 1, this is 0, and then our answer will be 1. So that's going to be the answer to the first problem if you want two pairs. Okay, now for the second problem, we have 4, 2, 1, 2. And we want one pair, and so for that we're going to pick the two numbers closest to each other, right? So 2 and 2, and then our difference is going to be 0. And they also say that if you have no pairs, you want to return 0 as well. So the maximum of an empty set to be 0. So if p is 0, it can be in the constraints. You want to return 0. And the overall constraints for this problem are 10 to the 5th. So you're going to want a linear or an n log n solution. So when we find these pairs, like, what's the intuition? Well, we're obviously going to want to have numbers close to each other. So something like a sort might be really helpful, right? Because then we could say, like, the numbers that are going to be, like, let's say we sort this first thing right here. So we have 1, 1, 2, 3, 7, 10. And we're trying to find something for, like, this number. The two numbers closest to this number have to be this or this. So a sort is really helpful to know, like, at least where to start, right? So we are going to sort these. Otherwise, like, if they're not sorted, how do we even know, like, where to look? Like, do we make a hash map or something? It would be a lot harder. So, okay, we can sort them. And then you might think, like, okay, well, we can just, like, look for this. We can just look for pairs with, like, small differences, right? So if we have, like, two pairs, we can just say, like, oh, this is a pair and this is a pair. Well, that's pretty small. So let's just take these two. Well, maybe that works, but there might be a pair with a smaller difference later on. Like, how do you do that? And then this pair number can be really big. So how do you figure out, like, what pairs do you even want? And do you always want to take the number, like, when you have this one, do you always want to take this? Or, like, when you have this one, do you always want to take this one and this one, or this one and this two? Like, how do you decide? And you can actually see, it makes it really clear in this example. So if you sort this bottom one, and you have one pair, you actually want to take this pair. But if you have two pairs, now you don't want to take the two numbers that are, like, the same. Now you actually want to take, like, this. So the pairs can change based on how many pairs. So this gets really tricky really fast, essentially, is what I'm saying. And we need a better way to do this. And so instead of focusing on trying to figure out, like, when we have a number, do we want to take the one to the left, the one to the right? Do we want to take anything at all? We're going to rethink our problem, and we're going to rethink in terms of what's the maximum difference we can have and what's the minimum difference, right? So what's the maximum possible difference we can have here? Well, it's going to be the biggest number minus the smallest number, right? So the biggest possible difference we can have is 9, assuming we can have enough pairs, and the smallest difference we can have is 0. So instead of looking for pairs, we can just say, okay, well, let's say we tried to get some pairs where the maximum was a 5 or less, right? And we succeeded. So if the maximum is a 5 or less, that we know that, like, 6 will work, 7 will work, 8 will work, 9 will work. So let's just write out these maximums, right? So it's like 0, 1, 2, 3, 4, 5. So we try a 5, and we say, like, okay, let's just try to go through this array, and let's just try to find pairs with a maximum of 5 or less. And if that's going to work. And if it does work, then we can cross out this whole thing. Right? And then we can focus on this section. And if it doesn't work, if 5 doesn't work, then we can cross out this whole thing. And we can focus on this section. So what does that look like to you? Well, it's going to be a binary search. And like I said, an n log n solution will work. And because we're already sorting, you can almost think of binary search as, like, being like a free operation. And anytime you do a sort, you can do operations that are complexity n log n or n, and you can basically think of them being free because you already had a sort, so you already have n log n, best case. So now we can do that. So let's actually go through how we would do that for that, and let's explain why that's better than just looking for like which numbers to add to what, stuff like that. So let's go over here. So let's say we have our sorted numbers, and let's just say we have like 5. Or let's just say our number is like maybe not 5, maybe it's like 2, right? We want to find 2. How do we do this? And obviously our pairs would be 2. So now when we compare our numbers, all we really care about is that the difference is 2 or less. So if this difference is 1 or 2, it doesn't really matter because we're just looking for pairs now. Like if this difference is 1 or this difference is 2, it doesn't really matter. As long as it's 2 or less, we're just going to want to take the first pair we find always. Because if let's say we're like, well, maybe we don't want to take this one, maybe we want to skip this one, maybe we want to take like this and this, or maybe we want to take this and this. So this and this might work, but this and this works 100%. And then if you do this, now you have this part of the array to look through for the rest of it. And if you do this, now you only have this part of the array to look through for the rest of it. So you're always better just being greedy and taking the first pair possible at every single iteration that fits our criteria. Okay, so let's actually walk through this for this like example now, and let's show how that's going to work. So we have 2 pairs, and we're just going to do a binary search, right? So we're going to delete some of this stuff, and we're going to walk through, what this would look like for this example. So we're going to have a left over here. We're going to have a right over here. And then we're going to have some pivot values. So that would be like, I think 5 in this case. So we're going to try 5. And we're going to try to find 2 pairs that have, that have maximum difference 5. So we're going to find every pair we're going to find is going to be 5 difference or less. So we're just going to be like over here, we're going to say, all right, let's just compare this number to the next number. Is that difference 5 or less? If it is, let's just take that right away. So it is, so we're going to take that right away. And then we're going to go to this number. We're going to skip an index because we already took this. Then we're going to compare it to this, and we're going to say, is that 5 or less? Yes. So let's take that right away as well. Now we have our 2 pairs. And so 5 is a valid solution. So we're going to write 5 as a valid solution. So we're going to have like a result. We're going to say 5 could possibly be it, but we don't know for now. So now that we know that 5 is a valid solution, we know that this is irrelevant now because 5 is better than all of these. So we don't care about any of this, and we're going to be going left. So now our right pointer is going to be shifted over here, and now our new pivot is going to be this. So now we're going to look for 2. Okay, so we're going to look for 2 pairs of difference 2 or less. We're going to do the same thing. We're going to start here. We're going to compare it to the next number. Is that 2 or less? Yes. We're going to take that right away. Now we're going to go over here. Is that 2 or less? Yes. So we're going to take that right away. So now this also fits our criteria. We found 2 pairs with difference 2 or less. So now we're going to update our result to 2. And now we can actually delete this, delete this, delete this. So now our pivot value, or actually we want the pivot value. So the 2 did work. So now that we saved our 2, we don't care about any of this anymore. So now our right value is going to be over here. And then our new pivot value is going to be this 0. So we're going to try a difference 0 now. We're going to try to find 2 numbers with difference 0. So here we did find 1. Excellent. Now we go here. Is that 0? No, it's not. So then we're going to go to the next number. Like we're going to compare these 2. Is that 0? No, it's not. Then we're going to go to this number and we're going to compare these 2. Is that 0? No, it's not. Then we're going to go here, compare these 2. Is that 0? No, it's not. And then we're out of bounds. So we couldn't find 2 numbers that are 0 difference or less. So this is invalid. So if 0 was too small, now we have to shift our left pointer over here. And now the only value we have left is 1. So our pivot's going to be 1. So now we're going to try 1. So for 1, so let's try 1 over here. So this works. That's 1 pair. And this also works. That's 2 pairs. So now our result is going to be 1 here. And then we've exhausted our entire like array of numbers for the binary search. So now 1 is our answer. So that's kind of how you do it. Instead of focusing on getting the optimal pairs, like figuring out like, okay, how do I get the smallest pairs? You want to focus on, can I just get pairs that fit some criteria? And then it's really easy because if the difference between pairs is less than my number, I don't really care what it is. Like if I'm looking for pairs that are less than 4, I don't really care if it's 3 or 2 or 1. I'm not trying to find the smallest one now. As long as it fits my criteria, I'm just going to take the first one I can right away, and that's always going to be the best thing to do. Okay, and so here we would return 1, and then this would be the same kind of thing. You would sort it, and then you would try numbers from 4 minus 1 would be like your upper bound, which would be 3, right? That's the biggest possible difference you can have. And then the smallest possible difference is 0. So we would do 0, 3. Okay, so that's essentially what you do. So we're going to need a helper function to actually figure out these pairs. And then we're just doing a binary search from 0 to the biggest number minus the smallest number. And we're trying to find what's the smallest number that will succeed there. And that's what we're returning. All right, so I think now we have enough to be coding. And so let's do that. So what do we want to do first? Well, we want to sort our numbers, right? So we want to do nums.sort. Okay. Now we want to create a helper function that will take in some number, and then it will tell us, like, did that pass? Did we find enough pairs? Right? So we can say, like, def passed or something, maybe, and it'll take in some number. Let's just call that, like, who knows, diff. I guess diff might be a special value. Let's do, like, threshold or something. Actually, no, I think diff was fine. Okay, it was just different color. I thought it might have been a special value. Okay, so now let's actually think about, like, what we need to do here, right? Let me do it. Let me actually check. Just I am curious. No, yeah, okay. Okay, so now what do we need to do in our function? So we're going to make an index. So we'll just say, like, I equals 0, right? And then what we're going to do is, we need to go through number by number. But if we take the number, we need to skip the next number, right? So, like, in this picture, if we take this number, for example, that means this is a pair. So we need to skip this number. And then if we don't, then we can just increment by 1. So let's do that. And let's also keep track of our pairs. So we can just say, like, pairs equals 0, I equals 0, while I is less than length nums minus 1. We don't really need the last number because we're going to compare every number to the number after it. Okay, so if this is going to be nums I plus 1 minus, so if nums I plus 1 minus nums I is less than or equal to our difference, right? That means we have a valid pair, so we're going to do pairs plus equals 1. And then we are going to increment I here by 2. And then we also need to check, do we have enough pairs now? Because, like, let's say we found enough pairs, that's P, we can just return straight away. So we can say if pairs equals P, return true. And then our else case is going to be only increment I by 1. And then finally, when we're out of the while loop, we can return false. So that's our helper function, just to let us know, like, for some difference that we're looking for the max difference we're looking for, does that pass? Okay. And now we need to actually do the binary search. So we're going to have a left and a right. So left is going to be 0, and the right is going to be max nums minus min nums, right? The biggest difference you can have. Okay, and then now we just do while left less than or equal to right. We also need to store, like, we need to store the biggest or the smallest threshold. So we're looking for the smallest threshold, so we can just initialize that to maybe something like right? Because we know right will always work. Oh, also, we did forget one more thing. So if P equals 0, we need to return 0. So you can't have 0 pairs. So if P equals 0, that's like an edge case here. If you have 0 pairs, you need to return 0. Okay. So while left is less than right, we do need to initialize our actual, like, what we're going to be changing. So we can just say, like, result equals, we can make it infinity if we want to, because we're trying to minimize it, or you can also make it the right value. That's also fine. So we'll just make it right, because we know right is guaranteed to work, right? Because that's the biggest, like, threshold you can have. Okay. So now we have a pivot equals left plus right. On 2. Okay, so let's leave some space here. And then, so what are we doing now? Now we need to actually call passed, right? So if passed, and then what's the thing that we're passing? We're actually passing the pivot here, right? So if it passed, that means the threshold was reached. So if the threshold is reached, we can update our result to be minimum of result and the pivot. And then if our threshold is reached, we're trying to minimize it, so we are going to go left. So this is going to be r equals pivot minus 1. Otherwise, our threshold was not reached, so we need to increase it, right? Or like our difference wasn't reached. So we need to say else L equals pivot plus 1. And I believe we are guaranteed to have a valid answer here, I think. Because like I said, if like this right value has to always work, so but we're just trying to minimize it here. Okay, and I think that's actually it. Now we need to return the result, but I think that's actually the rest of the code. See how many mistakes we made. That would be ridiculous. I think it worked. Let's take a look. Nice. So it did work. Okay, so let's go through the time and space complexity now. Yeah, I was pretty shocked. Usually for my binary searches, I make a lot of mistakes. Okay, so for the time, we did a sort, so that's already n log n, right? Okay. Now this pass diff function is just it's going through the array, worst case scenario 1 time, so this is O of n. And then this binary search is log n, but we are calling n log n times. So this combined, right, would be also n log n, because we are calling this we're calling this past function every time, and we're calling it log n times, so that would be n log n as well. So we have n log n and n log n, so the time would be n log n here. And the space is going to be, so we sorted our array. This is all just, I think this is all just constant values. We don't have anything, like, we don't have any arrays or anything, so I think this is constant time. Right, we have a left or right result and pivot and stuff, but we don't have any actual dynamic values. We don't have any arrays or anything. So yeah, I think space is going to be O of 1 and time is going to be n log n. And yeah, I think that's actually we need. I am curious what Navi is. I wonder if it's like the Dota Navi or something. I have no idea. Okay, so anyway, yeah, that's going to be it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.